Hello students, from today onwards we are going to discuss the concepts of numerical methods in mathematics and particularly we start from the solution of ordinary differential equations. So you have already studied the solution of ordinary differential equations in your previous semester in analytical mathematics, and there is the solution of ordinary differential equations by the use of numerical methods. Okay, so this is the difference. There are many methods in numerical methods by which we solve given ordinary differential equations, and there are many methods like as Taylor series method, Euler's modified method, and etc. etc. Okay, so just we start from Taylor series method. So what's the Taylor series method? Taylor series method is just a method in which we use the Taylor series expansion, and I think you know the Taylor series. Taylor series, that's the infinite series. Uh, if y is equal to fx is a function, and we have to find the Taylor series of this function fx about a particular point, and suppose x is equal to a is that particular point about which we have to find the Taylor series, then that Taylor series is fx is equal to f of a plus h into first derivative plus h square by factorial 2 second derivative plus h cube by factorial 3. There is missing factorial 3, there should be factorial 3, and that is the third derivative, and so on. Okay, so similarly, if we write it about x is equal to a, then we can write fx is equal to fa plus x minus a first derivative plus x minus a to the power 2 second derivative of f by factorial 2, and similarly. Okay, what's this here? Fx, this fx is y, that means so y in numerical method we represent it by yx also for fx. Okay, and we start from the particular value of x, and that is generally denoted by x naught. Okay, so we write just the first value of y at x is equal to the initial value, that is x naught. Okay, so yx naught plus, in place of a there is x naught. Okay, so x minus x naught, and the first derivative of that function is represented by the y prime, that is the, you see here, y dash, that is the y prime at x naught plus second derivative of y at x naught, okay, into x minus x square, x minus x naught whole square by factorial 2, and similarly we go on. Okay, then if we put here x naught in place of a, then we get such type of expansions. And what's the traditional representations here? What is y naught? So what is y naught? That is, y naught is the value of y when x is equal to x naught. Okay, what is y1? Y1 is the value of y when x is equal to x naught plus h. What's the h? H is unit difference. Okay, and similarly we write it. Okay, so finally we find the Taylor series can be written as yx is equal to yx naught plus x minus x naught into y prime at x naught plus x minus x naught whole square by factorial 2 y double prime, that means the second derivative of y at x naught plus. Similarly we may proceed it, okay, for the third power and third derivative of y, okay. uh, Generally we write it y x naught is represented by y naught also, okay. So what is y naught? Y naught means that y0, y0 and y naught both are the same thing. So what is y naught? Y naught is the value of y when input x is equal to x naught, okay. So that means y naught you can write in place of yx0, okay. So that's the Taylor series. Taylor series is useful to solve the ordinary differential equation of first order, okay. And since it contains the initial value, that means the y, the value of y, initial value is y naught and the initial value of x is x naught. So y, it is also known as the method to solve the initial value problem, okay. So here are the meanings, the traditional meanings. That's y prime is dy by dx, y double prime is equal to second derivative, y third prime is equal to third derivative, and etc. So y prime x naught is equal to first derivative at x is equal to x naught. Okay. Y double prime at x naught, it means second derivative at x is equal to x naught. Okay, and etc. So that's the Taylor series, and in next video we will discuss the problems on Taylor series concept. Okay.